Yeah, absolutely. Thanks, Brian. So thanks everybody for your time today. What I want to talk to you about is slightly different to what Matthew was talking about, but it's also one of the very cool services that we think that will help you accelerate your development. As a default, LocalStack is something that we think as ephemeral environment, but we hear more and more from our users and customers that they would like to see some level of persistence within the LocalStack. And we currently do that in two ways, and they very unique use cases separately. First one is persistence, which allows you to locally enable, again, similarly like DMS, you can enable it locally already. And it allows you to keep the state of your local infrastructure. And when you restart your container, it will come back to the same well-known state. In this setup, most of the services are already supported. So let's say if you created SQS, S3, and you want to pause your work, come back another day, and continue on that, persistent is one of those features that you can use. And the other option we recently enabled and enhanced is called Cloud Pods. And this is what we're going to talk a little bit more about today. It allows you to take a point-in-time snapshot of the application and the infrastructure state together. And we're going to do a quick demo as well to showcase how that works. But effectively, you can restore your state of your application to a known state within seconds rather than minutes or multiple minutes in some cases. So how does it work? So we've got two options, like you mentioned, the persistence and Cloud Pods. Cloud Pods allow you to save and manage snapshot of your LocalStack instance. You can also use it to share the state and debug your applications collectively as a team. All the Cloud Pods that you saved within LocalStack are saved to our backend storage and you're allowed to share them with your team and make them public or private, depending on how you work on them. They also can be used to automate your testing in pipelines by preceding CI environments. We've got GitHub Actions and other options that allow you to automatically load Cloud Pods, whether from GitHub or from your local environment. And they create reproducible development in testing environments locally. So how would that look like? Let's say you wanted to create the S3 bucket, SQSQ, using these simple commands. At the end, you can save your pod and then restore it at a later date. And again, if you work within a team environment where you often work collaboratively on multiple features together, you can share the name of the pod and you'll be able to share that pod with your colleagues. So one way to manage pods was from the CLI, as you saw. The other way, also through our web application, you'll be able to see all of the pods that you save. And for those that are looking carefully, you also notice that we support versioning. So obviously, your infrastructure, your application will evolve over time, and we allow you to save multiple versions in response to changes to your infrastructure and application, as well as changes to LocalStack supported services. So what does versioning mean? Like I mentioned, you can save the version state of your application, and it will save state of services, data, and LocalStack version. Again, it allows you to add or remove services as application changes. You can see the history of changes as your services expanded or were changed. And also this allows us to ensure that as the new releases of LocalStack come through with new services and new capabilities, we continue to provide support and compatibility across these versions. And I will show you in a couple of minutes when we go to the demo section how the versioning looks like, what you can do with it, and what are some best practices around versioning as well. Something I briefly mentioned on, we can use Cloud Pods in your CI pipelines, again, to precede your infrastructure state and application state on your workflows. So to do that, on your environment, you will set up auto-load pod command, and that allows you to load not one, but actually multiple Cloud Pods at the same time. And what that means is that you could divide your Cloud Pods into similar patterns as you would develop your application with. So you could have a backend Cloud Pod, front-end Cloud Pod, and also the database or data state. So again, couple of the benefits of using Cloud Pods over using maybe your infrastructure's code tools is that further cuts down on the deployment time from minutes to seconds. Restoring state from Cloud Pods, it's very, very fast, and we'll see that live in a moment. It can also be integrated in such a way that if your tests fail, we can save the state of the Cloud Pod at the end of the deployment and save that and share that with your team as well from your pipeline or from your local development. And that way you can also version your infrastructure state for integration end-to-end or acceptance tests. So you know which state of infrastructure you're testing, you know which LocalStack version you're testing, and which services you were testing. The other option that we've recently added, and I'll cover this one and one more right before we jump into the demo. At the moment, all the Cloud Pods are stored within our platform. We store them securely in S3, fully encrypted. But for these organizations and groups that do need their own backend storage, we now allow you to use your own remote storage to save the state of Cloud Pods. You can use S3 buckets on AWS or Aura's compatible registry such as Docker Hub or any other ones that you may be using. So that way, not only you maintain the state of your Cloud Pods, but you also manage all the files and nothing gets stored directly in our platform. Now, there are some limitations because you won't get the full compatibility with our backend platform. But for these organizations that are more secure or consider state of the application proprietary, you may want to keep them in your own storage. Additionally, we have recently added pods end-to-end encryption. Cloud Pods are already encrypted by default with the SSE/S3 backend storage. So they're already natively encrypted in S3. However, we also allow you to use your own PGP keys or use a passphrase to encrypt and decrypt Cloud Pods. You can store the encrypted Cloud Pods on web app or remote storage options. Both of them are available. But if you were to use the encrypted Cloud Pods, you have to create new versions of Cloud Pods because you cannot combine encrypted and unencrypted versions of Cloud Pods. So that's one of the limitations that we do currently have. So I want to quickly jump into the demo and show you how that works on our sample application. So what we have is a service application that has a couple of standard services that you may have seen before, AWS API Gateway that will handle our requests and forward them to one of the multiple Lambdas we're going to create. And we're going to have a DynamoDB that will store our data. And we're also going to be restored from Cloud Pod. Now, we also have a front end that I'm going to show you how that would look like. So in this case, we have 3 Cloud Pods I'm going to load. So in here, I already have LocalStack running. And we're going to run these side by one by one. And I'm going to show you how that changes both in the CLI itself here on our web app and what do we get when we go to the actual URL of the application. So first, I'm going to load the backend of the application. And as you see, we're going to quickly receive all the Cloud Pod, iterate over the services that have been saved in that Cloud Pod, and load it up. So right away, you're going to see that we're loading Lambda, events, Cognito, CloudWatch, and a couple of other services. And now if I go to my browser real quick and show you the resource browser for LocalStack, you already will see that we have some services running. So API Gateway, CloudFormation, CloudWatch, and a couple of services that are required for these applications to work. And if I go back and now on the front end, we're going to restore more infrastructure to the same LocalStack instance. And we'll see here that we've got a couple extra services. And if I refresh here, that's also going to change. I can go to Lambdas. You will see I have all the Lambdas restored, fully functional, IAM, And for instance, API gateway here, which already has all the endpoints created. So now if I go to this URL, web app is free, we'll see that all of our infrastructure has been restored. The frontend is running. We can create a new node, and we call it test node, and a save. That would just take a moment, and the test node has been created. But we have one more Cloud Pod to restore, and this is actually going to remove our entry because we are going to restore the database in addition to the front end and the back end of the application. So now if I refresh my app, you will see that this node has been preceded by a Cloud Pod. So that what that shows us that not only the state of the infrastructure has been restored, but also the data can be stored and restored for preceding your databases. So that's one of the advantages of the Cloud Pods that we see, that you can really quickly restore your state of application, especially on things that are repeated and don't change very often. You can have that preceded in your CI or local environments for quick testing. So this was the first way to restore Cloud Pods to your local instance of LocalStack. I'm going to quickly stop LocalStack and restart it, and I'll show you that we have no services running in just one moment when I go back to the web app to show you the other way in which we can actually load the Cloud Pods. So if I go back here now to my LocalStack instance, you will see that no services are currently running, no data has been restored. So I'm going to open the Cloud Pod that we were looking at earlier called backends. And at the same time, I'm going to show you a little bit about versioning and a few things that I've mentioned. As you see, we've got currently 3 versions of this container, this Cloud Pod. And you will see that it was created by my colleague Harsh. It was created actually yesterday with LocalStack version 3.61 and with these services saved as a state for the Cloud Pod. If I look at the previous version, you will see that we added some services in here, that we've added logs and a CloudWatch, and also that the version of the LocalStack that was created with is version 3.51, whereas the current version is on the latest 3.61, and that's why we saw the change. So now from looking at the Cloud Pod here, we can actually load it into a default instance, which is the one running on my local machine. Or the other option that we can also do, and that's as a bonus, that's going to show us another service that we also recently released, that's called ephemeral instances. We can actually restore the state of this Cloud Pod into an environment that we manage and will be available for a short period of time for your tests. So as this is loading, in a moment in ephemeral instances, we should see, hopefully, that this has been loaded and we see a ephemeral instance of LocalStack created. So let's just give that a moment. As this loads, I can actually show you the other part of the application or the Cloud Pods. So if I look for notes, we have the front-end Cloud Pod as well, which in this case only has an S3, and similar way, it has the versioning, who was created by and when. And I'm hoping this has been started. Great. So as you see now, what we've created is an actual Cloud Pod loaded, but onto an ephemeral instance. So this is a new service that we've recently released as well, that allows you to use our backend platform, our SaaS platform, to create temporary instances of LocalStack, but running on our cloud. They offer the same capabilities as running locally and allows you to restore Cloud Pods, but can be easily integrated within CI, can be used as a preview for your environments and applications for end-to-end testing and acceptance testing, for instance. So this was the other way in which you can restore Cloud Pod and quickly test it and check whether it runs with the latest LocalStack version, whether it's compatible with your application, and so on. So if I go back to slides, this was our quick application. And also using Cloud Pods in ephemeral instances, which I was just showing you. You can inject the Cloud Pods into the ephemeral instance during the startup, or you can browse them just like I did, start from the Cloud Pod, and then load that into an ephemeral instance. Again, key benefits of this solution is the collaboration, like we did see previously of Cloud Pods in general. This extends that a bit further to allow you to create these ephemeral instances that you don't have to worry about configuration. We manage them, we instantiate them. You just need to worry about how long you need them for and which Cloud Pod you want to load. Again, often we see that there is use case for user acceptance testing, and can further save you time and cost by unlocking your developers by having these instances available almost instantly, as you saw, within 30 to 40 seconds. It was ready and preceded with your infrastructure and application code. So a few things that I wanted to mention about some best practices for Cloud Pods that we saw over time. And we recommend at the moment for a couple of reasons. First, is to use pinned versions of LocalStack with Cloud Pods to ensure compatibility. Because of the frequent changes of Cloud Pods and also of the LocalStack itself, we can't guarantee at the moment compatibility between releases of LocalStack. So for instance, if you are using LocalStack 3.5, and as we just released version 3.6, the Cloud Pods may not be compatible right away with that version. We have some processes that we can share with you how to migrate your Cloud Pods from one version to another, but at the moment, there are challenges or potential challenges with migrating from version to version, but we can help you on the individual basis or share some of these best practices here. You can merge multiple Cloud Pods or import them to a instance of LocalStack. But one thing at the moment we don't have is ability to merge multiple Cloud Pods when the resources overlap between them. So if your Cloud Pod 1 has S3 and the second one has S3, that will be overwritten. We're now working on a feature that will allow you to do different types of merges: left merge, right merge, override, or import everything. And the other suggestion we have is for each version change to provide a description of the change to the Cloud Pod. So for instance, if I go back to my browser here, hopefully that will go back, and look at one of the Cloud Pods here that I previously created. If I look at this one, I'm mentioning in the description to that update to infrastate v2 with SQS. So it's useful for your version control and for state management to mention in the description what those changes would be between each version of the Cloud Pod. And that was the quick demo and quick overview of the Cloud Pods. And I think we already have some questions lined up,